So in this video we will study about the weak acid and with a strong base titration example, how we can solve the questions. So what we can do here, that we will follow this flow chart, or we just, you can review my previous video, what are the steps and how we are going to calculate the pH. So solution containing weak acid, add strong base. What will happen here? Weak acid started reacting with the hydroxyl ion, so acidic neutralization reaction will occur and weak acid decreases, anion concentration increases. And calculate the new value of acid and anion, then use the Ka or acid concentration and anion concentration to calculate the hydrogen ion concentration, then calculate the pH. So from here to here, this region is called stoichiometric calculation, and it is divided into stoichiometric region and equilibrium calculation. So at each point below the equivalent point, the pH of the solution titration is determined from the amount of the acid and its conjugate base present at the particular time. So let's start one example in this question. That question is here: weak acid and strong base titration, 0.03 molar solution of benzoic acid, and this is the benzoic acid formula. Ka dissociation constant of acid is 6.5 times 10⁻⁵, which is very small. The volume of 0.050 liter is titrated with 0.015 molar of NaOH solution. Calculate the pH after the addition of these four different volumes of NaOH. So what we are going to do here, let's start to solve this question. So first they are saying, if we are going to add 0.05 liter of NaOH, right? So here you can see basically 0.03 molar of benzoic acid, and half of the molarity we have NaOH, and now we are going to add amount, volume is same. So what we will do, first we will calculate the M1V1 for the acid, right? So M1V1 for the acid will be, let me zoom a little bit. So zoom out, basically mole of acid is given M1V1, M molarity is 0.03 and volume is 0.05 liter, multiplied together it will give us 0.0015 mole of acid we have. How many moles of NaOH we are going to add? M2V2 0.015 multiplied by volume, basically it is like a half. So if you notice that in the previous slide we have seen that if we are at the half point, if you remember this slide, if we are in a half point, so pH will be equal to pKa, right? So we are, since half mole, so we are in half point, and half point means pH will be equivalent to pKa. So we know the Ka value is already given in the question, which is so we'll take the negative log of Ka to get the pH. So negative log of 6.5 times 10⁻⁵, and the pH will be negative log of this value, which is 4.19. So this was an easy question. We came to know that we are in a half mole of NaOH and of the weak acid number of moles, then pH will be equivalent to equal to the pKa. Next question is, if we are going to add this is 0.075 liter of NaOH. So let's move to the next question. We have already calculated the number of moles for the acid, which is M1V1, and we know this one, right? Now we have to calculate M2V2 for second condition. which is M2V2 means 0.015 molar and 0.075 liter volume. Once we multiply, we find out the number of moles. Now here you can see moles of acid are greater than the number of moles of base, right? So we are in the B and C region. This is B point and this is the C point, right? So we are in excess. So we are basically in the BC region, means we have to use kind of we are in the buffer region. So if we are in a buffer region, we have to use the Henderson-Hasselbalch equation. So for that, what we have to do, first we have to find out how many moles of excess acid we have. So acid, NaOH we added, anion will form and water will form. Water do not participate in the this equilibrium, so we will write ice chart. So initial concentration of initial moles of the acid and initial mole of NaOH we added here. This is anion was 0 and then change will be, so we have a small amount of NaOH, so that is why NaOH will be completely consumed. So we write 0.0011 mole of NaOH will be completely consumed by acid, and so base will be 0, and these many moles of excess acid we have. And how many acetate ion will be formed or how many anion will form, it will be exactly same, right? Because because it is a 1-to-1 ratio of molarity, 1-to-1 stoichiometric ratio. Now we know the anion concentration and acid concentration. So now we will use Henderson-Hasselbalch equation. pH is equal to pKa minus log is weak acid over its conjugate base. So minus log P and 6.5 times 10⁻⁵ and log the acid concentration and conjugate base concentration. Once you will solve this one, you can find out the pH, which is 4.63. So here you can see, as we are adding more and more NaOH, pH has increased 4.19 to 4.63. So now the third situation is this one. Now the third condition, they are saying we are going to add 1.1 liter 0.1 liter of NaOH. So let's start working this one. 0.1 liter means moles of NaOH, moles of weak acid we have already find out, which is 0.015 mole. Now we will find out how many moles of NaOH we have. So 0.015 mole of NaOH, and this is the volume of NaOH, total this much. So now you can see moles of acid and moles of strong base are same. So if we are both are the same, means we are at equivalent point. So here if you will see the previous slide, that we are in this region, moles of weak acid and moles of NaOH are same, but equivalent point is in the basic condition, basic pH. So what we are going to do, that we have to calculate how much salt we have. So 0.015 mole will react with the 0.015 mole of NaOH, will form same moles of salt, and this salt once will hydrolyze in the water or dissociate into ions, it will form anion, and we have to calculate how much. So basically anion will form, and this sodium will not react with the water. So anion will react with the water to form weak acid and base. So this is the initial concentration of anion, which is coming from the salt, and then initial concentration of acid, there is no acid, there is no OH, minus x plus x plus x and then we can use ice chart to calculate equilibrium concentration. Once we know equilibrium concentration, we can calculate the Kb value, and Kb value will be equal to x square divided by 0.015 minus x. So here we can drop the x because Kb is very small. And how we can find out the Kb value? Now this is very important thing, that the Kb value we have to use with this formula, Kw is equal to Kb multiplied by Ka. So Ka value is already given, and Kb will be equal to Kw divided by Ka, means 1.0 time 10 to the power minus 14 divided by 6. Ka is value is given in the question, which is here 6.5 times 10 to the power minus 5, right? So once we will divide 1.0 times 10 to the power minus 14, 6.5 times 10 to the power minus 5, and once we will solve, we will get this Kb value 1.5 times 10 to the power minus 10. So Kb value is very small, so that is why we are going to drop this change. Now Kb value will be equal to x square divided by 0.01, then x square will be this much, so we will take under root on both side to remove the square, and x value will be equivalent to hydroxyl ion concentration, and we will take the negative log of hydroxyl ion concentration to get the pOH. Once we will subtract from the 14, we will get the pH. So this was the third condition, how we are going to calculate the pH. And the last and fourth condition is this one, that they are saying that we have to, if we are going to add 0.125 liter of NaOH, then what will happen? So for that condition, we know the weak acid mole. Now we have to calculate number of moles for NaOH, molarity, volume, new volume, and if you see here, you are more than acid, the number of moles of base are more than acid, so we will subtract. Basically we are in the past of the equilibrium condition, equivalent condition. So now we are in this region, somewhere C to D, we are in this region, right? We already passed the equivalence point. So if we pass the equivalence point, we are in NaOH excess, and we have to find out how much NaOH excess is there. So what we will do, NaOH excess, how we can find out? Basically we have to subtract the moles of NaOH minus moles of acid. This is the moles of NaOH we have, and the volume, total volume is how many we added. Initial volume of acid was this much of NaOH was added, total volume of this one. Now we can find out the molarity. Molarity of excess NaOH will be number of moles divided by volume in the liter. Once you know the molarity of NaOH, that will be equivalent to hydroxyl ion concentration, and once we will know the hydroxyl ion concentration, we can take the pOH. We can calculate the pOH by pOH will be equal to negative log of hydroxyl ion concentration. Once we will know the hydroxyl ion concentration, we can plug the value here, and we can calculate the pOH. So pOH will be 2.7, and then we have to subtract pH to get the pH. 14 minus pOH, that will be equal to 11.3. So these are the steps for the weak acid and strong base titration question to solve pH and calculate pH and at different conditions. So you can review this question and solution to understand the basic steps.